as you solve this problem, I hope that you saw that right away, since we have a fraction equal to a fraction, that we're going to cross multiply. So I'm going to do a times 7, and I'm going to do 3 times 16. When we do that, we end up getting 7a equals 48 here. Now to finish solving it out, remember I want to be able to solve this equation, so that means solving it for the unknown, solving it for a. I'm going to need to divide both sides by 7. And so when we do that, in this case it gives us a decimal. Now, as a fraction it would be 48 over 7. But it did say specifically here to round your answer to the nearest hundredth, so that tells us to go ahead and go into decimal form. So we do the 48 divided by 7 to get that 6.86. All right, so this problem looks a lot like the last one we did. But it, of course, is a little bit more complicated looking because this one has this cosine of 60 degrees in it. And so we're going to need to solve this one through. But our basic idea about how we solve it is going to be the same. We have a fraction that's set equal to a fraction. So we're going to cross multiply. We're going to do 1 times a, which of course 1 times a is just going to be a. That's nice and easy. And then we're going to have to do 10 times cosine of 60. Now a note on this. It is not cosine of 600. I cannot multiply the 10 into the 60 because notice the 60, it's inside of cosine. The 10 is not. They're not like terms. They mean completely different things. The 60 is not really a 60, it's a cosine of 60. So it has to stay the same. So when I multiply it, I'm just going to write it as 10 times cosine of 60 here. Now at this point, in order to figure out this value, notice we have to know what cosine of 60 degrees is. What do you have to know about your calculator right now? It's got to be in degree mode. So, to make sure your calculator is in degree mode, not radians, this is always a nice, easy way to check. In fact, eventually you'll actually memorize a few of these values just because they come up so much. This is usually the first one. Sine of 30 degrees equals 0.5. Do that on your calculator here really quick. Let's make sure that your calculator gives you 0.5 as an answer.
Wait, why is it 30?
Because if it doesn't, it tells you something's wrong. Now, again, why did I choose sine of 30? Because this is just the value I always go back to check it. It doesn't have anything to do with the particular last problem we're doing. It's just the value I always go and check to make sure my calculator is set right. Now that we know that we're in degree mode, we can calculate our actual value from this problem. We can do the cosine of 60. Now cosine of 60 also equals 0.5 as it turns out. So since I'm doing 10 times cosine of 60, that means I'm doing 10 times 0.5. That's nice and easy. You don't even need a calculator at that point, right? 10 times 0.5, of course, gives us 5. And yes, that is our final answer that we're looking for. Now this problem, of course, looks a lot like the last one, right? But you're going to notice the last one was relatively simple, and this one's going to have a certain level of added complexity to it. So, how do we approach it? The first step is still exactly the same. We're still going to go ahead and start by cross multiplying. So I'm going to do 1 times 14. Nice and easy. That's going to give me 14, right? And I'm going to do b times sine of 77. But how do I do b times sine of 77? Well, all I can do is just call it b times sine of 77. And so that's how I'm going to leave it. Now, a little side note here. If you wrote it as 14 equals b sine 77, it means the same thing. Everything's going to be the same. All the work will be the same. It's just that your b will end up on the right side, whereas mine will end up on the left side. But all the operations will be the same. All right. At this point, remember what we're trying to do. We're trying to solve this equation for b. Well, right now, it's currently b times sine of 77 degrees. I need to get rid of that. Now, it can be tempting at this point to go ahead and just calculate what sine of 77 degrees is, but if you do that, you're going to have to be keeping track of a big, long, ugly decimal. I don't want to do that. That's a pain. So I'm going to leave it as sine of 77 right now, and I'm just going to operate it with that. But remember, sine of 77 is just a decimal. It represents some number that we just haven't calculated yet. All right, so if I have b times some number like that, if I want to know what b is, I'm going to go ahead and just divide both sides by that number. So I'm going to divide both sides by sine of 77 degrees.
Oh.
Now when we do that, on the left side, that's going to have the effect of canceling out those sine of 77 degrees because I'm dividing it by itself. The whole point of doing that is that it goes away. On the right side though, how do I do 14 divided by sine of 77? Literally, I make it 14 over, which of course means divided by, sine of 77 degrees. I just write it as a fraction. Now, this is what b equals. Because notice on the left side, it says b equals that. So this is now where we break out the calculator. Once I have it written as b equals, I then break out the calculator, and we're going to type it in just as you see it. If you're on a graphing calculator, you're going to do 14, then you press divide, and then you're going to press the sine button, and then you're going to press 77. That's on a graphing calculator. If you are on a scientific calculator, it feels a little different. On the scientific calculator, you do 14, then divide, but then you're going to press the 77, and then you're going to press sine on a scientific calculator. Whichever way you do it, if you do it correctly, you should get an answer here of about 14.37. Now these types of problems, these are ones that are going to be coming up a decent amount as we continue through our work today, but our work for today is also going to be put into context. Today we are going to be finding the missing side length of a right triangle when we're given an angle. Whenever an angle is involved, you will need to use sine, cosine, or tangent. You might be thinking, but I'm finding a right triangle part. Isn't that Pythagorean theorem? Yes and no. Pythagorean theorem only involves sides. If there's an angle involved that we know and have to use, Pythagorean theorem doesn't help us out. That only helps us out when we know two of the three sides. All right, so in order to use sine, cosine, and tangent then, we need to know the definitions of sine, cosine, and tangent. Now this is notes you took yesterday, right? So have these notes out in handy. You don't have to rewrite them down or anything, but you're going to be needing them as we go forward. It's also useful to be able to know these off the top of your head. So a little quick reminder, what is the memorization word that you can use to remember? Yep, SOHCAHTOA. Because SOHCAHTOA here, sine is opposite over hypotenuse. SOH. Cosine, CAH, is adjacent over hypotenuse. So there's our definition over there. And then tangent, same thing. TOA is TOA, telling us that tangent is opposite over adjacent. And if you remember SOHCAHTOA, it helps you to remember these definitions, which we will be using today. All right, now remember that when we're looking at these, we still must be working with a right triangle. Just like when we do Pythagorean theorem, you have to have a right triangle. So you're always looking for that little square in the corner to tell us that it is a right angle there. All right, so we're going to be taking a look at this problem. Please write down this problem on your paper, and then we're going to work it through and see how this ties in all these different pieces we've been talking about today. All right, so taking a look at this problem, you notice we're given information about this. Now that information would mean nothing without knowing what each side and angle was called here. A little bit of very quick review from geometry. Remember that angles, or vertices, if you will, are always named with capital letters. So you notice my capitals are always my angles, and that will always be the case. So when we see up here, that means the measure of angle C. That's all the little m means is measure. This means angle, and of course capital C means angle C. All right, and then here we're told that we know what little b is. Now little b, notice a lowercase b represents a side length. And so both of these, since they're lowercase, are talking about our side lengths that are involved. So just remember that going forward. Anytime you see capitals, it will be angles. Anytime you see lowercase, it will be sides. All right, now in this particular problem, we're given a bunch of information. We need to now put this into our overall picture here and be able to visualize what's happening. And labeling a picture is the best way to get started whenever you're doing one of these problems. So we know angle C is 27 degrees. So I'm going to put the 27 degrees down there. By telling us that that is 27 degrees, that tells us an all-important piece of information. It tells us that when we go to name sides in this triangle, they're all relative to angle C, where the 27 is labeled. Okay, we also know side B is 65, and we want to find side A. So I'm going to mark side A and C. Like, I might circle it as a way to make note to myself that that's the one I'm trying to find. But this is our starting picture. All right, the first thing we have to do is we have to look at our picture and we have to decide if we're going to be using sine, cosine, or tangent. I know it has to be one of these, remember, because it involves an angle. Every time it involves an angle, you're going to use sine, cosine, or tangent. Now, how do we know which it is? What do we call this side?
The hypotenuse.
Hypotenuse. And what do we call the side that we want? The adjacent. Notice the side that's not labeled here, like it's not the one I'm trying to find and I don't know it. It doesn't enter into it. So I don't care what this one's called. I only care about those two. So which of your trig ratios involves the hypotenuse and the adjacent? Cosine. That's why we need those notes, right? We need those notes because that's what tells us which one is going to involve hypotenuse and adjacent. So the first piece of my algebra that I write down is I write down cosine of 27 degrees. Because remember, it's always cosine of the angle. And cosine equals here. Well, remember, cosine equals the adjacent over the hypotenuse. What is the adjacent in this particular problem? A. Lowercase a. Keep track of whether capital or lowercase, of course. Over the hypotenuse. What's the hypotenuse here?
65.
65. When it comes to putting the stuff over here, I know which one goes on top and bottom because I know which one is adjacent and which one is hypotenuse. That's what tells me it goes on top or bottom. It's not about which one is unknown or known. It's only about which one is called the adjacent and which one is called the hypotenuse. All right, now that I have this, I need to solve it. Some of you can look at this and you're going to solve it naturally on your own, and that's fine. But I want to give everyone a method that you can always fall back on if you forget the overall process. And it actually goes back to something that we did at the start of class already today. I can actually set this up as a proportion. Because cosine of 27 degrees is just the same as cosine of 27 degrees over 1. And now doesn't this look just like the problems that we did earlier? Yeah. So take a moment, finish solving it out from here, because we've done something like this before. I want to make sure that we remember that process. All right, and so in order to solve it from here, we cross multiply. The great part about it is that 1 times a here is just going to be a, so that part's going to be nice and easy. And then when we do the 65 times cosine of 27, I just leave it as 65 times cosine of 27 at the start. Now that it is a equals, I can now calculate it. Notice in this case, I don't have to do any extra division because after multiplying, a was by itself. So I can now just do 65 times cosine of 27, which gives me about 57.92. And we're done. That is the length of side A. All right, we're going to repeat the same kind of problem and figure out what the missing side length is for this one. Notice a different setup, so we want to draw the new picture. Now remember, it is super important to include the picture here because if you just write down all the algebra that we're about to go through without the picture, you'll be able to see how to solve a problem, but you won't see how to set it up in the first place, which is really what this is about, is getting it set up. So, taking a look at our picture, the very first thing we have to do is decide if it's going to be sine, cosine, or tangent. We do that by deciding what do we call each of these two sides that we're working with. Notice I don't care about this one, so I'm not even going to worry about what that one's called. The two sides that I'm working with here are the hypotenuse and the adjacent. Now, I now go back to my notes and I figure out which of my trig ratios involves hypotenuse and adjacent. It's cosine again. And so we start writing down cosine of our angle. So in this case, that's going to be cosine of 55, because we're always going from that angle that we're given. And when we write the right side of this, remember, it always has to be, because our definition of cosine, adjacent over hypotenuse. So whichever one is the adjacent, that one goes on top. Whichever one is the hypotenuse, that one's going on the bottom every single time. And so this one ends up being 41 over b. That's what the picture tells us. So the picture allows us to go into this original setup of the equation. Once we know the equation, now it's the same work as what we did earlier in class. And again, you can solve this through different means. Like some of you might just think about multiplying both sides by b, that's fine. But I want everyone to at least have this as a tool, where you write it over 1, so it's a proportion, and then you cross multiply from there. Just notice that in this case, when we cross multiplied, we didn't end up automatically with b equals. I end up with b times the cosine. So this is the sort where we have to divide by the cosine. And so when we do that division, we end up with 41 over cosine of 55. Since it's now the b equals, I now can go ahead and just plug that in my calculator to get the value. In this case, that gives us about 71.48. And we're done. All right, now there's really 3 different variations about what these kind of problems can look and feel like. One of them is where you're solving for the variable being on the top of your fraction. One is like this, where the variable is on the bottom of our fraction. But the other is where we're trying to find a missing angle measure. So we're now going to take a look at what that would look like. So again, write down our original problem, and then we're going to work it through together. Now in the first problem we did, where we started with the picture, we worked from this angle. And so everything was relative to that when we named the sides. In the second problem, which was the last one we just did, we worked from that angle, because that was the angle we knew. In this problem, which angle are we going to go from? Because we don't know either of those angles. But we are trying to find an angle, right? If I label my picture with the stuff that I'm trying to find and that I know those two side lengths, the 15 and the 13, and I don't know angle C. Because C is the angle I'm looking for, this is the angle that we're going to be going from. So when we name our sides, everything is relative to that angle. So now let's go ahead and name our sides. What do I call the 15? Hypotenuse. What do I call the 13? That's the adjacent. Because remember, we're going from this angle this time. So which involves the hypotenuse and the adjacent? Cosine. Notice my theme for today, basically I ended up having us use cosine for all of these. It's not because they all will be cosine, but rather just because I'm kind of making us focus on one tool at a time. But you're getting the same basic idea. It could have resulted in sine, or it could have resulted in tangent. Our work would look the same. It would just have a sine or tangent instead of a cosine in the work. So when I set it up, notice I wrote cosine of C. It's always cosine of the angle. In this case, I don't know the angle, so I put the variable name in for it. So cosine of C equals. Now cosine, of course, it still equals the adjacent over the hypotenuse. So I'm going to plug in the adjacent side on the top, and I'll plug in the hypotenuse side on the bottom. And so we end up with cosine of C equals 13 over 15. All right, now that I have this, we need to figure out how to solve it from here. Now you have actually seen problems that look kind of like this. We did them yesterday in class, and you did them on last night's homework as well. When our unknown is inside of cosine, what do I do to both sides to get rid of that cosine? Yep. This is where we use that inverse cosine. That cosine to the power of -1 thing. So I'm going to be doing inverse cosine of both sides, because that cancels out regular cosine on the left side. But of course that means it's now in the right side. Remember, I'm applying inverse cosine. I am doing inverse cosine of both sides here. I'm not dividing by it. I'm actually doing inverse cosine of both sides here. From here, again, we have what our variable equals. It's by itself over there. So the last thing we have to do is just the calculation. So we're going to do inverse cosine of 13/15. On the graphing calculators, remember, you're going to press second cosine, and then 13 divided by 15 equals. If you're on a scientific calculator, you start by doing 13 divided by 15 and get that number. And then you do second cosine. And if that calculation works correctly, you should get 29.93 as our answer there.